Let's solve this system of rational equations. The first thing you want to do is set them equal to each other since they both equal y. So I'm going to take this and I'm going to put it first. But as I go, I might as well factor it so I can see what I'm really dealing with. So this numerator is going to factor. X squared, of course, is x times x. 6 is either 2 times 3 or 1 times 6. Let's try 2 times 3 first. Now, inner plus outer must equal middle. Inner, I have 2x. Outer, I have 3x. To get a middle of 5x, I would need for both of these to be positive, which means these would be positive. And a positive times a positive is a positive 6. So that's what we want. So now let's factor the denominator in the same type of way. X squared will be x times x. 3 will be 1 times 3. And inner plus outer equals middle. Inner I have 1x, outer I have 3x. To get a middle of 4x, I need both of these to be positive. So positive and positive. And a positive times a positive is a positive. So this is working. So I factored that. Now I'm going to continue and set it equal to this other fraction, which is x over x plus 3. Now one way to solve these equations is getting the denominators to be the same. So both denominators have x plus 3, but this denominator has x plus 1. So I'm going to put an x plus 1 in the right-hand denominator, and that's okay as long as I also multiply the numerator by x plus 1. Now real quick, let's mention the excluded values. Looking at the denominator, if I set x plus 1 equal to 0, that tells me that x cannot equal negative 1. If I set x plus 3 equal to 0, I get that x cannot equal negative 3. So just watch out for that. Now, once I have the denominators the same, I can cancel them out. And I can make a new equation using the numerators. So just looking at the numerators, but I'm going to go ahead and multiply this out. So I'm doing a double distributive property here. So x times x is x squared, x times 3 is 3x, and then 2 times x is 2x, and 2 times 3 is 6. Distribute here, so that's x squared plus x. So this gives me x squared plus 5x, combining these like terms, plus 6 is equal to x squared plus x. Anytime I have x squared and x, I'm going to get 0 on one side. So that's my goal. So I'm going to go ahead and subtract x squared from both sides. And I'm going to subtract x from both sides. So this is unusual. It happens to cancel out perfectly. So this is gone. So combining these, I have 4x plus 6 equals 0. So I can just go ahead and get x by itself. So I might as well subtract 6 from both sides. And that will give me 4x is equal to negative 6. And then I can divide both sides by 4. So that will give me x equals, and this reduces, so that's negative 3 over 2. Now remember, well, first of all, notice that that is not an excluded value. So negative 3 over 2 is okay with me. This is a system of equations, and we started off with y equals this, y equals that. We have y values, not just x values. So we have our x value of negative 3 over 2. Is that what it was? Yeah. But we also need to find the y value. How will we get the y value? We will use one of these two equations. Now this one seems the simplest, so I'm going to use it. Y equals x over x plus 3. Now, when the equation and my value are very simple, I just substitute them in by hand. If they look a little awkward, cumbersome, I use a calculator. I'm going to go ahead and use a calculator since I don't want to deal with having fractions inside of fractions. So I go to my table, feature, and I type in the y equation. So x over x plus 3. X over x plus 3. Make sure you're in Ask X mode. Okay, whoops. I meant to delete. Delete. Now, I want to evaluate the function at x equals negative 3 over 2. So I can just type in negative 3 over 2 like this. Bam! I get the y value that goes with it. So that is negative 3 over 2 comma negative 1. So that means the answer is right here. It is B.